So hello friends, we are dealing with the problem solving session for modern physics. So for this one we are beginning with problem number 5.260. The problem is stating an isotropic point source emits light with wavelength 589 nanometer. The radiation power of the source is 10 watt. Find the mean density of the flow of photons at a distance of 2 meter from the source. So let us start this problem by understanding it like this. So let us consider that this is the point source which the problem is talking about, and over here we are considering this one, the distance at which this is discussed, that is 2 meter. So at a distance of 2 meter from the source, so the light rays will be emitted in all directions from this isotropic point source. So as it spreads in all direction, the photons will be scattered in the entire spherical area of 4 pi r square. So if we begin with this energy corresponding to each photon, energy corresponding to each photon, then we write it as E equals hc by lambda. Now if n photons are scattered per second, then we can say that the power emitted is equal to n times hc by lambda, where n is number of photons scattered per unit time. So if we calculate the value of number of photons radiated, then it is equal to p lambda by hc. So this is the total number of photons that is radiated per second. Now as we can say that this number of photons is scattered over this entire area which we are considering of radius 2 meter. So we are considering that the radius is r. Then we can say density of photons, so we can say that the number is n upon 4 pi r square. So if we solve this, we get p lambda upon 4 pi r square times hc. So this is the required value that we have. So let us substitute the values which we have. So as the problem is stating that we have a wavelength of 589 nanometer, which can be written as 589 into 10 to the power minus 9 meter. Then power source is of 10 watt, and we are discussing it at a distance of 2 meter. So then the number density, which we calculate as p lambda upon 4 pi r square hc, can be written as 10 times 2 upon 4 pi, r square is again 2 square, and then hc. Over here we need to put lambda. So we put lambda is 589 into 10 to the power minus 9 upon hc 6.6 10 to the power minus 34 times 3 into 10 to the power 8. So if we substitute all these values over here, then we get the value as 6 into 10 to the power 13 per centimeter square per second. So keep this in mind that we have taken this entire thing in SI unit, but since the answer is given to us in centimeter square, so we are putting it in terms of centimeter square and we are converting into centimeter square per second.